This is Miss Steele's Precalculus class, section 7.5, day 1. We're going to be talking about and learning how to solve trigonometric equations. So examples 1 and 2 ask us to find all solutions of the equation in the interval 0 to 2 pi. So number 1, we have 2 times cosine of x minus 1 equals 0. In order to solve for x, we just need to get x alone. So first step is to add 1 to both sides. So we're left with 2 cosine of x equals 1. Our next step is to divide by 2. So we have cosine of x equals 1/2. Now we have to ask ourselves, what value or what angle gives the cosine value of 1/2? Thinking of the unit circle, we know that at the angle pi over 3, we have a terminal point of 1/2 square root of 3 over 2, which tells us our cosine value of pi over 3 is in fact 1/2. So we know one of our x's will equal pi over 3. And since it's positive 1/2 and not negative 1/2, we know that we can't have anything we can't have an angle in the second quadrant, and we cannot have an angle in the third quadrant, because referring back to all students take calculus, cosine is positive in the first quadrant and in the fourth quadrant. So now we just need to think of the angle that has a reference angle of pi over 3 in quadrant 4, which would be 5 pi over 4, or 5 pi over 3. I'm sorry. So the two values for x in the intervals 0 to 2 pi is pi over 3 and 5 pi over 3. For example 2, it asks us again to find the solutions in the interval 0 to 2 pi, but this time we have tangent squared of x minus 1 equals 0. So our first step again is to add 1 to both sides. So now we have tangent squared of x equals 1. To get rid of that the squared, we need to take the square root of both sides. On the left-hand side, we're just left with tangent of x. And on the right-hand side, we are left with 1. But anytime we take the square root or fourth root or any even root, we are left with 2 answers, and that's the plus or minus. So now we have to ask ourselves, what angle gives a tangent value of 1? Thinking of the unit circle, when our theta is pi over 4, we have a terminal point of square root of 2 over 2, square root of 2 over 2. And since tangent is y over x, at pi over 4, tangent is 1. So we know one of our values for x will be pi over 4. And since we're trying to find when we're trying to find the angles where tangent is positive 1 and negative 1, that means that we will have the pi over 4 reference angle in all 4 quadrants. So this tells us we have pi over 4, 3 pi over 4, 5 pi over 4, and 7 pi over 4. Our next example asks us to find all solutions of the equation. Example 3 is cosecant of x minus 2 equals 0. We're going to solve this the same way. So start out by adding 2 to both sides. So cosecant of x equals 0 or equals 2. I'm sorry. Now, since it's a little difficult to think of cosecant, let's change this in terms of signs. So 1 over sine of x equals 2, which tells us that sine of x is equal to 1/2. So now, thinking of the unit circle, we know that at pi over 6, or 30 degrees, we have a reference angle or a terminal point of square root of 3 over 2, 1/2. So at pi over 6, we have a sine value of 1/2. So one of our x values will be pi over 6. Now we also have to think a different quadrant where sine is positive. Think back to all students take calculus. Sine is also positive in the second quadrant. So the angle in the second quadrant with a reference angle of pi over 6 is 5 pi over 6. So right now we have x equals pi over 6 and x equals 5 pi over 6. If our directions were to say find all solutions on the interval pi or 0 to 2 pi, like the previous two examples were, then we would be done. We'd have all the answers. However, our example asks us to find all solutions. So, something to note. Since sine of x is periodic, we know solutions repeat. We know solutions repeat on intervals of 2 pi. And that's just because the period for sine is 2 pi. The same thing goes for cosine. So with this being said, this tells us that we need to add 2k pi to create all possible solutions. This k just represents the number of periods that you want this to repeat. So our final answers would be x equals pi over 6 plus 2k pi, and x equals 5 pi over 6 plus 2k pi. So those are your final two answers. For example 4, it asks us to find all solutions of the equation again. So we have 2 cosine squared x minus 7 cosine of x plus 3 equals 0. This equation is very similar to 2u squared minus 7u plus 3, which we know that this equation factors into 2u minus 1 and u minus 3. So just replacing the u's with cosine, we know that this equation will factor into 2 cosine of x minus 1 times cosine of x minus 3 equals 0. And we have two equations. We have 2 cosine of x minus 1 equals 0, and we have cosine of x minus 3 equals 0. So now just solving for cosine of x, we have to subtract 1 and divide by 2, so cosine of x equals 1/2. And on the other equation, we just need to add 3, so cosine of x equals 3. So for cosine of x equals 1/2, we need to think of what angle makes a cosine value of 1/2. This refers back to example 1 in the notes. So we know at pi over 3, cosine is positive 1/2. And since cosine is positive in the first quadrant and it is positive in the fourth quadrant, we know that the angle in the fourth quadrant that has a reference angle of pi over 3 is 5 pi over 3. So we know that x equals pi over 3 and x equals 5 pi over 3. Since cosine has a period, or cosine's period is 2 pi, we just have to add 2k pi to both of our solutions. So x equals pi over 3 plus 2k pi, and x equals 5 pi over 3 plus 2k pi is our solutions for the first part. Now looking at cosine of x equals 3. Think of, if we were to solve for x, this would be x equals cosine inverse of 3. But thinking of the domain of cosine inverse, we know that the domain is between -1, and 1. With this being said, we know that there is no solution. So the only real solutions we have are the ones we originally found for cosine of x equals 1/2. So our last example is tangent of x times sine of x minus sine of x equals 0. We were asked to find all solutions. So the first thing we should notice is that we can factor out a sine of x. So once factoring out a sine of x, we are just left with tangent of x minus 1 equals 0. So now we have sine of x equals 0, and we have tangent of x minus 1 equals 0. So first, looking at sine of x equals 0, we need to think of what values for x gives the sine value of 0. First one is at 0, or 2 pi, where we have a ordered pair of 1, 0. And another one is at pi, when we have an ordered pair of negative 1, 0. So now, writing out our equations, we will have x equals 0 plus 2 pi k, and this includes 0, 2 pi, 4 pi, 6 pi, and so on. And we'll also have x equals pi plus 2 pi k, or 2k pi. So this includes pi, 3 pi, 5 pi, 7 pi, and so on. But looking at these, kind of easy to notice we only need to use one of the solutions, because if you just add pi to one solution, you get the other. So our solution could just be x equals 0 plus pi k, or 0 plus k pi, or just k pi. Looking at the second part, tangent of x minus 1 equals 0, we first need to solve for tangent of x, so tangent of x equals 1. And from a previous example, we know that the value for x that gives a tangent value of 1 is pi over 4. And tangent is positive in the first and third quadrants, where this theta value is 5 pi over 4. So now our two formulas that we have are x equals pi over 4, and instead of adding 2k pi, we just need to add k pi, and that's because the period for a tangent graph is only pi. So we have x equals pi over 4 plus k pi, and x equals 5 pi over 4 plus k pi. So if we have x equals pi over 4 plus k pi, the values that includes is pi over 4, 5 pi over 4, 9 pi over 4, and so on. If we have x equals 5 pi over 4 plus k pi, that includes 5 pi over 4, 9 pi over 4, 13 pi over 4, and so on. So in understanding this, we only need to use one of these solutions, because if you just add pi to the other solution, or to one solution, you get the other. So we just need to choose one. Let's just say x equals pi over 4 plus k pi. So then finally, since we need all solutions to find all solutions of the original problem, tangent of x times sine of x minus sine of x equals 0, the final answer is x equals k pi, and x equals pi over 4 plus k pi. So that is all I have for you today. The homework is on page 568, numbers 1 through 19 odd.